Welcome everyone. I'm excited to kick off today's presentation on refinery equipment, design, installation, and O&M, which is part of our Technician Guide series. In this session, we'll explore both static components like heat exchangers, vessels, columns, valves, flanges, and rotary equipment such as pumps and compressors. We'll cover key aspects of their design, installation, and operation and maintenance. So, let's get started and dive into the essential details that keep refinery operations running smoothly. Let's talk about safety and permits, which are crucial elements for maintaining a safe work environment. First, we have lockout/tagout procedures. These are essential for ensuring that machinery is properly shut off and cannot be accidentally restarted while maintenance or repairs are being performed. It's about preventing unexpected energization that could cause injuries. Next, personal protective equipment, or PPE, plays a vital role. This includes items like helmets, gloves, safety glasses, and hearing protection, everything that keeps workers safe from hazards. Wearing the right PPE is non-negotiable when it comes to safety. Finally, work permits are formal authorization documents that confirm a specific task is safe to carry out. They help us manage risks by ensuring proper planning, communication, and safety checks before starting work. All these elements, lockout/tagout, PPE, and work permits, are interconnected and reinforce our overall safety culture. They remind us that safety isn't just about individual actions, but about following established procedures to protect ourselves and others. Let's take a closer look at piping basics. When designing and installing piping systems, there are several key components we need to consider. First, supports are essential. They hold the pipes in place and prevent unwanted movement or sagging. Next, anchors serve a similar purpose but are often used to fix the pipe at specific points, especially where movement needs to be restrained. Guides are also important. They allow for controlled expansion and contraction of the pipes due to temperature changes, helping to prevent stress and damage. Lastly, bellows are flexible elements that absorb vibrations and thermal expansion, protecting the integrity of the entire system. Understanding how supports, anchors, guides, and bellows work together is fundamental to ensuring a safe, reliable, and efficient piping system. These components are the backbone of effective piping design, linking all the elements of our overall theme of system integrity and safety. Let's talk about pumps, which are fundamental components in many systems. A typical pump consists of several key parts that work together to move fluids efficiently. First, we have the casing, which surrounds the internal components and helps direct the flow of fluid. Then there's the impeller, the core part that actually imparts energy to the fluid, creating the flow. The shaft connects the motor to the impeller, transmitting power smoothly and reliably. The seal is also crucial. It prevents leaks and keeps the fluid contained within the pump. Lastly, the motor powers the entire operation, providing the necessary energy to turn the impeller and move the fluid. Understanding these components helps us see how pumps operate effectively and how each part contributes to the overall performance. Let's take a closer look at compressors, specifically the screw compressor, which is a common type used in various applications. The core components of a screw compressor include the rotors, which are essential for compressing the air or gas. These rotors work together in a precise manner to generate the desired pressure. Adjacent to the rotors, you'll find the coupling, which connects the motor to the rotor assembly, ensuring smooth power transfer and synchronization. Proper coupling design is crucial to prevent vibrations and ensure efficient operation. Another vital aspect is the oil system. The oil not only lubricates the moving parts, but also helps in sealing the compression chamber and dissipating heat. An effective oil system is key to maintaining the compressor's performance and longevity. By understanding these components, the rotors, coupling, and oil system, we see how they work together to ensure the compressor runs efficiently and reliably. This interconnectedness highlights the importance of each part in achieving optimal compressor performance. Let's now take a closer look at heat exchangers, which are essential components in many industrial processes. When we talk about heat exchangers, The most common types you'll encounter are shell and tube, and plate heat exchangers. Each has its unique design and application depending on the specific needs of the system. Shell and tube heat exchangers consist of a series of tubes enclosed within a larger shell, allowing fluids to flow on the outside of the tubes or inside, facilitating efficient heat transfer. Plate heat exchangers, on the other hand, use thin plates to separate the fluids, offering a more compact and often more efficient solution. Another critical aspect of heat exchangers is the use of baffles. Baffles are structures inside the shell that direct the flow of fluids, improving turbulence and heat transfer efficiency. They ensure that the fluid moves across the tubes multiple times, maximizing heat exchange. Gaskets are also vital components. They create a tight seal between different parts of the heat exchanger, preventing leaks and maintaining system integrity. Proper gasket selection and maintenance are crucial for the safe and efficient operation of these devices. So, understanding the design features like shells, plates, baffles, and gaskets helps us appreciate how heat exchangers are engineered for optimal performance, which ties back into the overall theme of efficient energy transfer in industrial systems. Let's take a closer look at vessels and columns. These are essential components in many chemical processes, and understanding their structure is key. On this slide, you'll see the terms separator, column, internal trays, and nozzles. Starting with separators and columns, these are the main containers where separation of different components occurs. Columns are often packed or equipped with internal devices to facilitate this process. Now, internal trays are a critical feature within many columns. They help improve contact between the vapor and liquid phases, increasing separation efficiency. Think of them as platforms that allow better mass transfer. Nozzles, on the other hand, are the entry and exit points for fluids. These are where feeds enter or products leave the vessel. Proper design and placement of nozzles are vital for optimal operation and to prevent issues like flooding or inefficient separation. Connecting all these points to our overall theme, understanding the design and function of vessels and columns helps us optimize separation processes, improve efficiency, and ensure safety. So, when we're designing or maintaining these units, paying attention to these elements is crucial. Now, let's take a closer look at valves and flanges, which are essential components in piping systems. Here, we're focusing on gate valves, which are commonly used for on-off control. A gate valve consists of several key parts. The body is the main structure that houses the internal components. The bonnet is attached to the body and provides access for maintenance. The disc is the part that moves up and down to open or close the valve, controlling the flow of fluid. The gasket ensures a tight seal between the body and the bonnet, preventing leaks. Understanding these parts is crucial because they work together to ensure the valve operates smoothly and reliably. This knowledge helps us appreciate how each component contributes to the overall integrity and functionality of the piping system, which is vital for safe and efficient operation. Now let's talk about commissioning, which is a crucial phase in ensuring our system operates smoothly and reliably. During commissioning, we focus on installing and verifying each component properly. This includes the pump, which is the heart of our fluid movement, the valve, controlling flow and pressure, the instrument, providing essential measurements, and the blind flange, which seals off sections when needed. It's important to understand that each of these elements plays a vital role in the overall system performance. Proper assembly and testing of these parts ensure safety, efficiency, and ease of maintenance down the line. By paying close attention during commissioning, we set the foundation for reliable operation and long-term success. This step really ties into our broader goal of creating a robust and well-functioning process system. All right, let's wrap things up with our O and M cheat sheet. On this slide, we're highlighting some of the key components we need to pay special attention to: bearings, seals, gaskets, O-rings, and bolts. These elements are crucial for the reliable operation of our equipment. Bearings, for example, are what allow rotating parts to move smoothly and efficiently. Seals and gaskets prevent leaks and keep contaminants out, ensuring the integrity of the system. O-rings are a specific type of seal, often used in tighter spaces, and they're vital for maintaining pressure and preventing fluid leaks. Bolts hold everything together, so proper torque and installation are essential to avoid failures. Understanding these components and their maintenance is central to our overall goal of reducing downtime and extending equipment life. Remember, paying attention to these details can make a big difference in our operations' success. So, keep this cheat sheet handy as a quick reference, and always approach these parts with care and precision.